Okay, now we're going to do number 45 from section 5.1, but I want to talk about some ideas here before we do this. And remember, we know that the sine squared of x plus the cosine squared of x equals what? Well, that equals 1. And from that, we can just find the cosine or the sine. So I know that the cosine squared of x equals what? 1 minus the sine squared of x. Okay? Now, there's another form for this we can use. All right? Now, if we think of this, and let's go back and review our algebra 1. Okay? If we've got a squared minus b squared, that's the difference of perfect squares, right? The square root of a squared is a, and the square root of b squared is b. And we know that that factor is to be the product of the sum and the difference of these little numbers, so a plus b, a minus b. All right? We know that. Well, if I look here, is 1 a perfect square? Sure, what's the square root of 1? 1. Is the sine of x, well, it's sine squared of x a perfect square? Well, that's an abbreviation. Remember, this is an abbreviation for the sine of x squared. That's what that's abbreviated for. We just don't like to write the parentheses all the time. Okay? So this is a perfect square, and what's the square root of that? Just the sine of x. So I can always rewrite this as the product of the sum and difference of these little numbers on top. So this factors to be the product of the sum and the difference of these numbers, 1 plus the sine of x and 1 minus the sine of x. So once you take the cosine and you write it like this, you could always break it up like this. All right, I want you to keep that in mind when we're doing number 45. Okay? Okay, does that make sense? Now, again, it's just algebra. And remember, I told you it's algebra, but instead of using a's and b's, we're using sines and cosines, that's all. Okay, does that make sense? Okay, now let's take a look at 45, and let's see how this awareness will help us. Okay, so here's number 45, and the left looks pretty bizarre. And we've got one fraction on the right, and it's going to be kind of hard to square this binomial. I could square this out. I could use the FOIL method and square this out, but I would have a big old mess. And what I mentioned before is that sometimes it's better to put everything in terms of sine and cosine and get one simplified fraction first before you do anything. So that's probably the safest bet. Get one fraction and then square it. Then you just have to square the numerator and the denominator rather than have this binomial with a bunch of secants and tangents, which can be pretty difficult. First of all, and second of all, I've got a fraction over here. If I square this out, I'm going to get a trinomial, so it's going to be harder to build that into a fraction. So let's get sine and cosine first and see what we can do. So this is going to be the same thing as, and the secant is the same thing as what? 1 over the cosine minus the sine of x over the cosine of x. I'm not going to worry about the square yet. I'll put a question mark there because we don't know that those are equal. And then I'll try to get one fraction, which is pretty nice because it's already got a common denominator. So, gee, I lucked out here. So I've got 1 minus the sine of x all over the cosine of x squared. That was pretty easy, wasn't it? Now I can square that. And see, I've got a fraction over here, so if I square this, I'll get rid of these brackets so I can maybe get going here. So I'm going to square this. Square the top and square the bottom, so I've got 1 minus the sine of x squared all over the cosine. And we can say square root of x. It's the same thing. Okay, so we're squaring it. We square the top and we square the bottom, right? Just like if you had x over y squared, that would be, again, you can think of it from algebra. X over y squared is the same thing as x squared over y squared, right? Those are one of our basic algebra properties for exponents. All right? In other words, the square of a quotient is the quotient of the squares, or the power of a quotient is the quotient of the powers. All right? Now, we've got we're starting getting to more like what we want. All right, let me write it over here so you can see this. 1 minus the sine of x all over 1 plus the sine of x. Notice how we're getting closer now. Getting closer. Okay, now remember, I've got sine x, sine x, sine x. I got cosine x, so this is kind of the oddball. But remember we talked about there's a very easy way to change this to be into the terms of the sine. Remember the cosine of x, remember the sine squared plus the cosine squared equals 1, so the cosine equals 1 minus the sine squared. Remember from our Pythagorean identities. I'll go back over here to what we did a little bit ago. Remember? Sine squared of x plus the cosine squared of x equals 1, therefore the cosine of x equals 1 minus the sine squared of x. So that's what I'm going to do. Some of you smart guys probably know what we're going to do next. Okay, so I got 1 minus the sine of x squared all over, and this is going to be 1 minus the sine squared of x. Okay? And then if I look at the bottom, let me just look at the bottom first here. Give myself a little room here. Remember we talked about this. This is the difference of perfect squares. If this is a 1, and that's a sine of x, I've got the difference of perfect squares, so I can write this as the product of the sum and the difference of these little numbers. So that's going to be 1 plus the sine of x and 1 minus the sine of x. Is that all right? Okay. Now, I'll just write this out. I'll expand this out. Anything squared, x squared is x times x, so 1 minus the sine of x times 1 minus the sine of x. Okay? So I expanded that out, and I think you can see what's going to happen now. Remember, we're trying to prove this to be 1 minus the sine of x all over 1 plus sine of x. And what can I cancel over here on the left side? The 1 minus the sine of x's. And there you go. So we've done it. Checked. Okay? So this is a good review of factoring, difference of perfect squares, all of our identities. It's a real nice problem. Really like that one. Okay? So I hope you can see how that works. Try to thoroughly understand it, because that's how you master this subject, and everything we're supposed to cover is by understanding all these steps and why they work. Okay? Hope that one helps.